So you were supposed to, stay here for was 9.81 times T. That was 6. The projector is fired toward the wall, 50 meters away. The wall is 30 meters away. Okay? Where? Yeah, I'm not saying.
How do you do that with this one?
Hey, John,
Nice for now.
this one,
Yes.
just what is it? This one is what is it? You get it? You get it, you get it, serious. You get it in negative direction. And what I'm looking for is speed, not velocity. When you subtract, what do you do? The ball is projected, that is.
I thought it's 9.76. No, so
Sure. Yeah, sure. 68.94. 9.81 of that and 87.6. When it goes on, you can't do that. That's nice. Have you converted?
we'll get some nutrition from because it's when you multiply each one,
The president introduces
yes, was essentially
like
together.
this one.
Yes,
When did you give this one? Résultat réaliste. Je vais accompagner de l'hostilité. Vivi pani gościu nie ekspozyta na rodzicy. Byłaj gościu z co? Gdy niestety, gdy nie jest z ręki, wspomniałem. 6. Breathe. Breathe. Body is breathing. It's tired. Hands rising entirely. Put it there. So, aircraft flies totally at 250 meters per second at altitude 1.2 kilometers. So that's height about 2 kilometers down to 1,200 meters. And speed of 250 meters per second, which represents UX. I recognize the time of flight and before the package reaches the ground. As this, each customer to see as well as the person. I want the first package, which is the ground. I'll tell them. Regarding the launch stage one impact, as far as I believe, blah 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 blah. Do something. The next one awareness. Conductivity in terms of stress, because of the Fourier's law. of conductivity. Further up on there, we have three other reports in this physics. Number one, on the hundreds to establish and fail. On this one, we have the this one. Right? This is explanation of equations. Dt over L thickness is recursively equal to power due to emissivity, where we depend on Poisson vector, area and third order temperature. We're going to working out Very important. Very well. Put it special. Put it on his punishment. That's 4 minutes. Like the next 4 minutes. It's not my time. Which one my time? No. My head just wrong. Just writing a mess. Resume companies. We have views and etc. It's an alpha. It's an alpha. We call it alpha. So you have to try to resolve the vertical. Just about some really ignorant attention. You cause alpha. So, no, the point where this is the vertical component of S of the variation to be equals to 0. This makes which is this point. We have sy equals to 0 plus 1 g c squared. That's right. Equals This one is 0. 0 is equals to 2y. So y is 0. Just out T. Long to Jason. You sign alpha A into G sign alpha
Sir,
to square.
I'm not driving, sir.
President,
I'm not driving.
trajectory,
I didn't get you, sir.
trajectory on an example.
Okay.
So we have G sign theta square equals to G sign alpha plus sin theta. Let's show what is wrong. Evet, o yüzden bizim is well,
I have a question. What is the this side alpha T square? This side theta T square. When you move to the other side, it should be G sine theta, not G sine alpha.
the resolution of the vector from A is negative.
That G sine theta goes like G sine alpha.
It did not resolve it. The vector is supposed to be negative range from A. That's why I did not. Considering the fact that the vector is going up, it's supposed to use negative. I left it positive. Yeah, from this place. I'm supposed to put negative. But I'll still get there. So. From there, you have 0. Then you have 0 equals to Six. Oh, this one gonna be.
Okay.
Yeah.
Something like, under what returns are the internet?
And
Under what like education practices using so like
first from the level of physics. It's not beyond your scope. I'm just trying to tell you, if you want to understand it, you first of all have to understand your normal basic projector.
Another question.
Yeah.
Did you something that stands for the initial velocity when this was right?
Sure.
They use an alpha.
Mm-hmm.
So what would be the final velocity?
That's
It's projected horizontal.
why it's the why I'm looking for the point where your component of velocity will be z max 0.
Yeah, zero.
So
So
that
when projectile projection, like to the horizontal, your V, which one is zero?
your vy component
Okay.
is 0 at maximum height for any type of velocity. For example, projectile, whether angular projectile, trajectory, angular across plane, vy component at max is 0. Does not mean velocity is 0. Only vy components 0. And that's why I'm using 0 here. I'm using the initial component of vertical projectile. Then this one here is representing the component of gravity that acts normal to this angular projectile. That's this one. Across this way. There are two here. You can see the G sin theta here. And the G cos theta.
Okay, the one that is acting projectile and parallel, that's basically, we call that like the resultant or something.
Which one?
The G cos theta.
G cos theta cannot be resultant. G sin theta cannot be resultant. The resultant velocity cannot show. They cannot show fractionating index to measure identities. It is this G, the numeric one.
Okay, the one that is projected
That
onwards.
is zero.
Okay.
So whenever you're doing components, once you did cos theta, sin theta, it's not the result. That's not the resultant vector. That's the component vector.
So, sir, what we're basically saying is that all our questions in physics boils down to vector analysis.
Yes, everything depends on your approach.
Okay.
If there are some aspects of physics that you might not need to resolve.
Like what aspects?
There's a bit of physics that you need to resolve. For example, if you are dealing with the whole of modern physics, majority of the aspects they're not talking anything class. Most of them are talking quantum, quantification, abstract, trying to make abstract look discrete. So in that place, how do you come across what you're doing this one? Your radioactivity. Did you ever use component of radioactivity?
No, sir. But you said that impossible can be possible.
A little bit right now, and it's still true. It's very true. You might be the one to start.
So you will be the one that you are hearing.
So when that happens. So but it's just the reality of physics. Some things can't be broken down into components in length in space dimension. Some things limit themselves to the dimension they exist. You can't have a time dimension for a length parameter. That's just how it is.
So what about reference points?
The reference point is talking about how you view it, but as scientists, we don't care about your perspective of view. We care about the inertial reference frame. That's where a reference frame where each person's scientific report can still consolidate one way or the other. So even if we want to proofread a person's write-up, there will be a standard to proofread because we're writing from The other one that arrive from different places, we're making a report on the same event.
So can we call that we are
Vectors.
no, not vectors. So can we call that like we are forming answers because we're trying to like invent all our opinions together.
Forming answers.
Yes, now in reference to you cannot use only your opinion, you cannot use only my opinion, you cannot use only Angel's opinion.
The thing is that one thing I know is that I try to avoid is your personal opinion. Nobody's personal opinion is in a book. That's just the truth. Many of these guys they have their personal opinion, but you can't document it in the book. What will be documented are only theses that have practical proofs. Like they will literally take you into labs where you see what they wrote. Maybe when you have personal relationship with them, they can open up things about what they think and what they feel. It's not in the textbook about Einstein wrote that he also wrote how he feel about physics being a lie. Those things spread from his conversations with his close clique. But he didn't document it in any textbook that the whole of it was like. If not, nobody will study it again. If your mentor tells you that the thing is reading, you found out at the end that none of it is true. Won't you stop?
So they're saying that get close to you now, you tell me your opinion of physics.
What's going on when you What's going on when you
You have some opinion, I mean you're breaking world record now. You have some opinions of breaking the world record.
What's everything is just experimental. Everything you just find out, everything has experimental reasons.
So fake lie.
Experimental reasons, you take life. Now, you take life is something that not really experimental. Like if you are not experimental, you are just spontaneous. And this is even more serious.
They're just moving anyhow, you don't have the pressure.
But let's move this planned.
So it's spontaneous.
No, it's planned.
Oh, it's
No, I don't know that they're moving spontaneous now.
so we are moving anyhow.
So basically, that's how physics is. That's how it is. Science generally, the whole of science generally does not work on if there to be personal ideology. So many arguments that happen in the past could be happening today.
So if it was personal ideology, we will have Newton's thoughts on physics. We will have Colomb's thought on physics. Might have Henry's thought on physics because we have opinions too.
You know, most of the people that have personal thoughts, as we're obviously not experimentally proven, that their documentation ended as hypothesis. They didn't push any of it. Then you mentioned four hypotheses, you know.
Avogadro's?
Hypothesis.
Avogadro's the hypothesis. It's not a law that see it was not proven.
Avogadro's. Your teacher's not really listening now.
So the teacher said it was hypothesis, so
Who?
you.
What is hypothesis?
You want.
Your own. Avogadro's not hypothesis.
Avogadro's, he was certain about his law.
The thing is that was the real law. Because this law has confinement and a reader. You know that haven't you seen a law that works generally in the universe without any constraints or any condition for its working? You understand? Except from few, you get
What that is, sir?
like relativity. That's the only law that works. General relativity from our medicine. Special relativity and general relativity, they work both on Earth, outside Earth, the universe as a whole. That one now, I don't get the best is explaining it to you. You have to meet him.
But it's there, sir.
And look for him. And just look for him.
Okay, sir. Can we solve questions on flow rates, moving flow rates?
Yeah.
Oh, yeah. Don't give me a hard one.
Why isn't it just going to no, don't talk. I'll still be right now.
You will not write, we'll solve it together, sir.
Yeah.
Yeah, question one. Question one now.
Let's start from the derivation of this equation. What happened? How are we the what's problem? Continue. Okay, I should ask you a question too.
Yeah.
Okay, what aspect of dynamics, fluid dynamics?
Let's go to Stokes law, laminar flow, turbulent flow, Reynolds number.
So do you believe in vortices?
What believing?
Do you believe in vortices formation during turbulent flow? If yes, where did you see it? Why do you think it's true? You're just the one talking na. Validity of people's experimental. And I'm sure that you that used to carry times already, I don't know stuff. So do you believe vortices?
No, because I've not seen it before.
So you're living your life.
I'm
Then you want
I'm
to
spontaneous. Did you say my life began?
and listen,
So I remember you called me Olodo yesterday. I can't forget
you prove this to yourself.
me.
You prove that one to yourself.
Sir.
You said me.
Okay. I think I'm going to get the business I'm doing.
Not impossible.
Also, now I see the possibility can become possible.
No, sometimes that might just be what it has been. Maybe just
Now resolve with activity.
really down to our elders.
You are our elders. You always listen to the ancestors. Don't forget.
You should really go to the
Resolve.
radioactivity.
No, sir.
Let's try and resolve some things.
No, sir.
Actually, I think it's possible because
See, great minds.
no, it's there's a possibility in it because there is actually nuclear force. But I don't know. I don't know what they're waiting for to put this to some people.
They're
But
waiting for you.
people will be writing such already
They're waiting for you.
because no, people will be writing such
Oh,
because you decline certain people's model of their atom claiming it does not explain how nuclear stability came to be. Right? And we know that nuclear stability has something to do with forces. And not only people. And force is the vector. Although it's the kind of action that occurs in radioactivity because around tensor actions. Higher ranked.
okay, sir.
Okay.
So sorry about solving questions of fluid dynamics.
Alright.
Oh, yeah.
Well, So, it's your face. Why are you laughing?
Was only questions on fluid metrics.
Okay.
Okay. Yeah.
Okay. There's no project. Project. Okay.
Yeah. Generally, our questions are going to come from Stokes law, Bernoulli's, Reynolds number. I can't hear you, sir.
Yeah, let's see on the two.
So our questions are coming from Stokes law, Bernoulli's, Stokes law, Bernoulli's, laminar flow, turbulent flow.
Okay. So, what's the plan? How is it going to be? How is it going to be involved?
I'm acting and ready for you, sir. Yeah.
First, Mr. Andy, do you have any documents of those things? I just want you to like can have something to work with. So you're ready for me?
No.
I was not doing to sound though.
Yes.
Okay. Let's start from the assumptions of Stokes law.
Okay.
So, there are different kinds of Stokes in physics. We have Navier Stokes. We have many range of Stokes. So, if I'm beginning about diffuse Stokes, where we'll be considering small spheres and small hard smooth spheres, right? Out of the 5 forces that act in the fluid, which of those forces needs to be resolved to 0 for the vector force in that fluid to obey Stokes law?
I think there's a question.
How many forces are in the fluid? Where are you people? Yeah. So how many forces act? How many forces act in the fluid?
How many forces are in
Yeah.
5 forces?
Good. What are their name?
Buoyant force, viscous force, and obtuse. Obtuse actually fluid. Obtuse was have buoyant force.
In a scientific conference like this, I'm planning to go through
So everyone said rotational force acts on the fluid.
is it like you feel it's a like
Not really, sure.
staying one side, you feel it's a like I don't believe that there's anything in this earth that is residing in this earth that gravity know at all. So the 5 forces that act on the fluid, right? They tend to define a certain property of that fluid. And our understanding of those properties sometimes makes our ability to relate with certain branches of physics much easier. And I asked that question. I was thinking from the perspective of the fact that bulky fluid making something the number of things it carries if you understand the forces, you find out that the whole thing is still speaking the same language. We want to have buoyant force, we want to have, let me know which is what we want to have. We want to talk about buoyant force, we want to talk about turbulence forces, we want to talk about compressibility forces. You understand? Yes. And one thing is that some of these forces, they work hand in hand to create an equation on their own. Like for example, if you keep a fluid incompressible, what you are really doing to that fluid is that you are altering one of the internal properties, or let me use the intrinsic properties of that fluid, something like density. You understand? So, like it makes the idea of the fluid change. So we can no longer define the fluid as being ideal or non-ideal. Or do I have non-ideal fluids? No, I don't know if we have. Do you think we have non-ideal fluids? You know that there are ideal and non-ideal solutions for fluids.
We have general fluid law.
What is general fluid law?
I'm not saying.
What is general fluid? You just said it. I'm here for the first time. General fluid law. So, is there anything interesting that you can bring up on the fluid and help us demonstrate? Yes. Just make things happen. Let's start with the
Awesome.
Angel. We didn't even ask a question. Just say anything about fluid. Okay, me, I want to ask a question.
Okay, sir.
The common secondary school question. Why is it difficult to turn grease from one container to another container compared to turning water from one container to another container? Let's just identify the property of the distinction there.
Because grease is a viscous fluid, so the resistance to flow.
So, is the resistance to flow right?
Yes.
So are you now trying to say that viscosity is a frictional force?
Yes, because there's a resistance to the flow of the fluid. And frictional force, what is the resistance between two bodies in motion?
But the bodies are not fluids. No, the American. The bodies are not fluids now. Why the body is fluid? You can't say for yourself that you are a fluid. No, I'm not a fluid. I have some part of me that are made up of fluid. I'm made up of fluid.
Made up of everything. I'm made up of 70% water.
And that does not make me a fluid now.
And you're half fluid.
And that does not make me a fluid. I cannot sum up my whole composition to just fluid.
Are you saying that viscous force is not a frictional force?
Viscous force is in the similitude of frictional force in your general dynamics.
So viscous force is a type of frictional force.
No.
Then
You want to make me put friction? No. The viscous force in the world of, in the terrestrial world, viscous force is performing the same function as frictional force.
so under fluid mechanics, viscous force is a frictional force.
You can say that
Okay.
under fluid mechanics.
Okay.
So, and we know there are different kinds of viscous force.
Yes.
There are different kinds of viscous force.
Can you tell us like
Viscous forces and viscosity are they the same? When you say viscous force and you say viscosity, are they the same?
Can we say viscous force and viscosity are the same? In a way, yes, we can.
You don't like to be in one place. You talk like a politician. You want to be in two sides, so anywhere it tilts. you will complete the. Is viscous force? Is it viscosity?
Anyway, yes, because viscous force is the force that resists the flow of the fluid, and
Okay.
viscosity is the resistance to the flow of the fluid. So the force has the action for the fluid to not move, to the tick to not come out of the rubber. So yes, you can say viscous force. In a way, it's a type of viscosity.
The way it sounded now, it sounded more like you are no longer in complete agreement about viscous force being a frictional force. You are now sounding like you are changing viscous force to inertia.
No.
You said you used the word resist. We were talking about oppose before.
Mm-hmm.
And you are doing resist, sounding like reluctance
But
to pour out.
But viscosity is the resistance to the flow of the liquid. It is not the opposition to the flow of the liquid.
Let's think about what you are saying very well. Viscosity is the you say it's not the opposition.
In the literal definition that you give us in class, it is the resistance to the flow of the
Bring your notes.
I know it is not resistance.
Now, the thing here is that we use the word reluctance whenever you want to change the state of motion of the body. That's when we use the word reluctance. You can't use, before you use the word opposition to something, you are already negating a movement. There's a movement in place that you want to negate. You understand? But if I start telling you that I want to initiate the reluctance to something that is already in movement, you understand? That one now makes it more like a conflict or identity. We're no longer clearly describing what we're talking about. So if I ever use the word reluctance with friction, it will be kinematic viscosity. When we're talking about reluctance in transferring content from one container to another. That one is the reluctance. You actually turned it and it's not coming out. Maybe because of the thickness and all those things. That one is the reluctance. But friction, we are literally already in motion. This is very we're already in motion now. I should use it. Isn't that helpful? So doesn't that mean that? So the point is, viscosity, kinematic viscosity, you can use the word reluctance to transfer of content from one container to another. But when you're talking about viscosity in a fluid, that's when you're talking about dynamic viscosity. You can't use the word reluctance.
How do you use resistance?
Exactly.
A resistance is opposition. Think about it in literal sense. When you're
It's not always.
thinking about it in literal sense, resistance is an opposition. When you're resisting something, like in friction, when the body is resisting, the body is basically opposing that force.
Yeah, it's true. How I said.
Yes.
Do you know that if I'm resisting a movement, all I just want is for that movement not to happen. If I'm oppositing the movement, that means I have an anti-movement I want to initiate that is not in line with the intention of this present movement. So friction is not friction can drive you. You understand? Friction can't move you. Friction cannot be the reason why somebody is on the road moving. You understand? Like I don't know if you get what I'm saying. I'm not saying it does not take part in force balance, but you say that I'm moving left not because of the force applied, but because friction is the only force moving the front. It's not possible.
If you were going to define friction, how would you define friction?
Friction is the opposition to this direction of motion. Now we are not opposing to the magnitude, we oppose the direction of motion. Remember that motion, when you discuss motion, you discuss motion from different perspectives. It's a broad thing. Vector perspective of motion, right? We have magnitude and direction. So if we're mentioning friction as opposition, we're talking about it is opposing the direction of your motion. It cannot induce a specific movement in that direction. You understand? Once it puts you or tries to prevent you from going where you want to go, maybe or try to move east and stops you from moving east, it can't force you to move west. It can only keep you at that inertial spot. It can't actually move. So even in government, I'm not even a person though. But I don't think there's any politician and good person that is just opposing it, that is just resisting the movement. They have an intentional, they have an agenda not to push. That's a friction has no agenda in terms of that initiating, like directing an actual motion. It's just hindering you. Some people will say the only way you will ever see something happen is when they say, oh, I refuse to reduce the friction of the company. That's this Galilean argument of reducing it for raise frictionless level. You find out that without force, bodies can move. And that one's there. But it's not friction that did it. They literally remove friction and making the surface smooth. So for friction, this one now is from the textbook. The textbook supports friction as opposite the direction of motion, right? But you can't define friction like a complete vector force that has it can help. Like for example, a force can move you in a specific direction. Friction can move you. This is why that friction is a frictional force. It cannot move you in a specific direction spontaneously. You need it's only one way it can happen. You need an inclined plane. And there is an angle to which you push yourself.
So you can't say that friction is a resisting force that occurs when two bodies are in close contact with each other.
That's the definition.
Then, if you're saying it's a resisting force and you're saying it's opposition,
Resisting force. When we use resisting is because of limiting friction. Friction has types. When we use the word resisting, that means we're talking about limiting friction, static friction. We don't want you to start moving. We are resisting you. But when you get to dynamic friction, you are already in motion. We are trying to oppose this motion you are trying to initiate. You understand? That's kind of dynamic friction. You get it? But what I'm saying and what brought us here is viscosity.
viscosity, so
Viscosity, is it friction?
under fluid mechanics, viscosity
This kind of I record this game. Let us hear you. Sincerely speaking, is viscosity friction?
under fluid mechanics, yes.
No, wait. Leave under fluid mechanics.
We're talking for under fluid mechanics, you can't leave up fluid mechanics or zero fluid mechanics.
Okay. So, upthrust, is it normal reaction?
Under fluid mechanics, yes. Because it's downward force. And normal reaction is downward force. And upward is the one
Normal
that.
reaction is upward.
In that inclined normal reaction is downward.
Okay, so I know you're trying to. Normal reaction is perpendicular to the surface, right? So, if the plane is inclined, it's going to be perpendicular. And that still feels upward, just upward to the left or to the right.
So when you are solving questions on inclined plane and you draw the plane, your normal reaction, it goes down. No, it goes up.
You can't go correct yourself. I thought I was trying to wonder what she said.
It goes up. So we can say yes, under fluid mechanics, upwards is a type of normal reaction.
What you're saying is correct. But me, I'm not asking you on that. Is upthrust a normal reaction?
Upthrust is a normal reaction under fluid mechanics.
Okay, the thing there is that under fluid mechanics, do we have normal reactions?
You have normal reaction, that's all.
Wait. Okay. Even you have to. So without upthrust, well, it's obvious that you understand. I'm sure you understand.
Sir, I will start from the first time.
I'm trying to extract good questions.
Dr. Kashim.
No problem. And Mr. D, how far now? Is something. Okay, is that what the question? Let's use question. Let's just resolve the questions.
Sir,
Yeah.
when you were not number delivered on 2000, what kind of food do you expect?
When it goes down below 2000,
Yes,
that's the laminar flow.
that's a parallel food. I mean, there's no
Laminar flow.
parallel.
Laminar flow. Laminar.
So please define laminar flow.
Laminar flow just goes beyond just being parallel. It must be streamlined. That means even if it is not, even if there is an attempt to be a disturbance, if the disturbance is not enough to form a vortices, the whole that whole disturbance will move in a coordinated manner. It will still be streamlined and you will come back to it. So it is laminar. As go.
Can we have a Kobe laminar flow?
You know what the every curve is still a line now.
Yes,
It's curved line.
yes.
So it can still be, you can have a curved laminar flow because we know of something we call curvilinear translatory motion. So meaning that in as much as the coordinate distance between the extremes of that part remain equidistant to themselves, then they are still being concordance now. You know.
The dominant flow is a zigzag type of laminar flow.
You can call it that. You can call it that. That's what's it. Okay, still question. Go on. Do you find what's your favorite of physics? Your favorite branch of physics?
Modern physics.
When you're talking, and you know, I don't think I've ever been in a physics discussion where we're talking classical physics because we know that it's a faulty type of physics. It's a faulty physics.
I like politics.
There's this man, he said that he had to be a very good liar and a relative liar to teach physics. Since then, what's that? Print. No. Come here. Just read it. Read it for who? Okay, well now. Stokes' law. A small spherical particle of radius 0.5 millimeter in density, 2,500 kilogram per meter cube, falls in water. Mu is given as 1.0 times 10 raised to the power of minus 3 Pascal seconds. Density of water 1,000 kilogram meter cube. Determine the terminal velocity of the particle. Check if Stokes' law is applicable. Okay? That's the question now. Yeah, oh. She counts of nation. So in this question now, what's the plan? So let's just start from identifying that terminal velocity. What does it mean?
Maximum velocity at which the body falls in water when the purpose of the upward displacement and downward displacement are equal.
That's the same thing as saying uniform velocity achieved in what in the fluid.
Yes, sir.
Okay, so what formula is coming to your mind?
I don't think we can use Stokes' law because we don't have a drag force.
Okay. So what do you plan to use? Well, look at the diagram very well. You see, we don't have the drag force. Look at the diagram very well. The place the labeled FD is what?
That's the drag force. I'm not giving a value for the drag force
Well, you can see that the drag force acts in the same direction
with the weight.
with the weight. So the magnitude of the drag force is the weight of the object. This question. Yeah, do answer. Answer. So once we're done with this question, I want to be running through all the topics in physics. I want to bring out some controversies. I don't know who owns this calculator. I just did it and I need around and just do. Yeah? So, picture. Yeah, that's what's supposed to.
It's close to the
I don't know that's what's supposed to slow. It's supposed to be God now, you're crying.
I'm not crying. The same thing is Stokes' law is applicable.
They asked it there. Okay, so do you want to come to that conclusion because it's there? So why? What are the conditions? That means you have to let us know the conditions upon which
You're supposed to follow all the assumptions, the conditions of this Stokes' law was not supported.
for Stokes' law to work, the object must be small. The object must be a sphere. 2. Those two are they satisfied here?
Yes, sir.
It must be viscous. 3. Is there viscosity in that place? There is. Your voice is going low. Is there viscosity? The fluid must be incompressible. And thank God, what we are seeing there does not look like a gas. Is it gas?
It's water.
It's even water. So is water compressible? And the flow, if it's going to be in the tube, has to be laminar. That means low Reynolds number. And now we're not going to deal with a fluid, with a flowing fluid. So this thing has been kept in the container. And it's something else that is flowing inside. Then lastly, the sphere must move at low velocity. Meaning analysis that not handle it low. But in as much as it could achieve terminal velocity. Because it takes time. It takes time. You don't just achieve terminal velocity like that. All the forces have to balance out before you can achieve that. So what is it you find? Velocity, have you? Okay, so why not try out other variations of Stokes' law? Like velocity equals to your, do you have your change in, do you have your density there? You have your density there. Do you have the density of the ball? Did they give you the density of the ball there?
Yes.
Did they give you the density of the fluid as well?
Yes.
They gave you those two densities.
Yes.
And they gave viscosity.
Yes.
Then you can work now. You can use 2r square open bracket, the changes in this, the difference in their densities divided by 9 viscosity. That should give you your answer. The terminal velocity. Terminal velocity. Terminal velocity should be equal to what? By r open bracket, the difference in the densities g divided by 9 viscosity. Depending on how you represent viscosity, this is our conventional way of representing it. But anyhow they present it, that's still fine. But that's what you work with. Let's do that. Solid before fluid. Solid before fluid. Like when I mean solid before fluid, like the density difference. Density of solid minus density of fluid. 0.817. What method do you use? This one here. That's what you use, and that will give you the answer. So not looking for. See another one on the board. Fluid lovers. See another one on the board. See now. Mr. Dave, ever ready? If you have, why there's something else? If you have a velocity time graph like this, velocity time graph like this, who can describe the motion? Who can describe the motion of this velocity time? Velocity time. Yeah? Who can describe this motion? This is a velocity time. Yes. Mm-hmm.
Going up like this.
Okay.
Is accelerating.
Okay.
Velocity changing and tilting.
Okay.
Going down is decelerating.
Okay, so hold on. Whenever it goes up like this, it is accelerating. Okay?
If it's going down, that's 0 points. It's decelerating.
So deceleration stops at the 0 point.
And going lower, it should be reversed.
Reverse it. What is reversing, please? Are you accelerating? Are you still accelerating when you're down?
Yeah, basically, we are still decelerating.
Okay.
We are going to that plan.
Okay.
Like, probably, like, you are like accelerating, but like the opposite direction. Like, you're moving to the opposite direction.
That's good. That's almost same to what you are saying.
So it's not the same.
Okay.
Going
Going up, let's use a car.
Okay.
You change it, see, while going up, the value is actually increasing, which is acceleration. Acceleration is increasing. Going down, the acceleration has increased, which is also called deceleration, like it's increasing.
Mm-hmm.
Then if you go,
Stop, don't, wait, hold on.
yeah,
Now, if I get you well, going up, the acceleration was increasing. I mean, your velocity was increasing because you are accelerating. Coming down, your velocity was reducing because you are what? Then when you get to zero and you continued going down, what do you think you are doing? No, you are not. Use the mic. I want to hear your thoughts.
okay, after that, you change the velocity per time. So velocity is like negative values. Yes. Like, and since it's going down, the final velocity will be more than the initial velocity.
I disagree. You can't tell anyone, even you won't tell anybody that obvious. Because it's going down now here. You said, okay, let me explain something to you. Example of where this thing can happen. Example of where it can happen is the projector. Do you know a body can move from here to here? Do you know if this body, the velocity it attained during the acceleration was 6? According to your statement, when you get here, you go to 0, but when you continue, you believe that you can't be going that fast because velocity is reducing. Hope you know that when you cross here, okay,
I'm saying you can still go that fast, but not in that same forward direction.
Okay.
Going backward instead.
who told you that that's backward? How do you know that you're not the one going backward?
I'm just imagining.
No, you know. Let me tell you something. Calm. That is why physics came tools, and they gave us these tools at the beginning of the course. The most important tool in physics is understanding coordinates. Do you understand that thing that they call coordinates? And understanding the quantity you are measuring. You cannot see. If you think it that way, that's when you start feeling that because this person has crossed here, it looks down. The fact you are going down, you are not up. See, it's just like me studying two people moving and somebody is using his back to run. And he's actually running faster than somebody who is moving. That does not change the fact that that person is back to move fast is accelerating. No. It's accelerating in a different direction. And that direction, you can't begin to justify the backward direction. Do you understand? Backward and forward are relative statements. They are what? Relative statements. If I'm standing here, I'm going to tell you this chair is in front of me. But meanwhile, this chair is not in front of the. You understand? It can't be in front of everybody. It's relative statement. So you have to make sure that you are discussing from a coordinated time frame. You understand what I'm saying? So from here, the motion goes to 0. When it gets to 0, it starts doing what? It starts increasing. It starts increasing in the negative direction. So if I want to report the motion of the body, I'll tell you that this person here probably attained 10 in the negative direction. My own is, if you were moving and you attain the speed of 10 meters per second, then the remaining part of it is the characteristics of vector that we call what? Senses. All vectors have senses due to their what? Sensitivity to spatial orientation, sign. You understand? Plus and minus. Those ones are just looking direction. The real deal is what? Is magnitude. So the question I want to ask now. They tell us right from secondary school. Why are you handing the mic over? They tell us right from primary school, secondary school that they tell us that The area under a velocity time graph is your what? Is your what? Now they told you this. They told you this. For you to know the answer, they told you to. They told me to. And they said it to you to grab. The velocity under a time graph is what? The distance. The area under the time graph is your distance. I mean, total distance travel. I can say yes to that here, right? Because this side now is area under the curve. But this one here, how do you want to explain this part now to a small child? That this thing here now is still under the curve. Because to me now, it looks like it is on top. Because if this is my curve, it's now on top of my curve.
Because that is under the negative y-axis.
Okay.
So that's basically, if you get to a small, I think that's in negative direction.
If that is negative direction.
Negative 10.
If that's like the change this comparison. Now this is what I'm saying. It is a wrong statement. Do you know why? It's a wrong statement. They found it difficult to be able to use right terminologies for conflicting parameters, distance and displacement. It is only displacement that is direction sensitive. So I can agree that it is your total distance, but to agree that it's your total displacement, that's not true. That's not true because this place here, like you said, is genuinely a reversal. It's genuinely what? Reversal. So there's every tendency that while this reversal is going on, look at something. What's the displacement of this body? You know there's possibility that the displacement of this body will end up in zero. Because I know that this is our vertical axis though, but the displacement is the shortest distance covered between 2 points. And most times, whenever anything forms a complete cycle, before you can form a cycle, you have actually touched the negative part of the motion as well. You explode the whole circumference of the motion. Do you understand what I'm saying? Do you understand what I'm saying? So, this kind of motion too can be like that. It can be giving you a very high distance. But at the end of the day, the displacement may actually be zero.
Why would the displacement be zero?
I did not say big.
Why might displacement be zero?
Good. Now, if I want to calculate the displacement of this body, right? You know, displacement is time sensitive. That means the displacement upward there will be a positive displacement. And the displacement downward there will become a negative displacement because you used a negative velocity. Do you understand what I'm saying? You don't get what I'm saying? What axis is this? What axis is this?
Negative y.
If I should add a positive parameter to a negative parameter, what does it give you? If they're equal, that's why I said it can. Do you understand now? That's why I said it can be zero. So you cannot come and justify that because you went down like this, that it means that that person is no longer moving fast. Because the person might be moving. This, I can turn this to a story. You were accelerating because you were heading to work, and when you got here, you saw that people were slowing down, only to get to this place and saw that no. When you see that the reversal motion, using the reversal motion is going to reverse the motion of your time graph. It's going to be forward, just like you're going to go to your. It will start showing that you're now moving in the negative direction. Those motions will now be happening under the direction of the motion, which is your principal x. That's how you measure it. And the total event you did here and the total event you did here are the same. It means that you didn't even displace. Because somebody who left his house to go to work, right? And for somebody to come back home, what is the person's displacement? Zero, right? That can be the motion of this thing too. You wanted to go somewhere, you got here, that's zero. You understand what I'm trying to say? It cannot be zero. So what I'm saying is if you really want to do in physics, understand spatial orientation. understand space. Because physics it explores space than any other. It explores space than time. You know, the universe is made of three major dimensions, right? Space, what in? Good. Mass, length, and time. And the only one thing that does not constrict or dilate, right, naturally, is mass. Every other thing can constrict and dilate. You get it now? So if you understand space, you understand motion properly. What's the something?
Sir, okay, if the velocity that you were using to initially was 2, was it 2 was it very small? And then he used 10 minus 10 immediately at the store. How do we have negative displacement? Or are we going to use magnitude?
You cannot negate the displacement. Because it is displacement, the sign is necessary.
Because of spatial.
Yes.
That line generally, like representing that from wires and its axis.
Which line?
Velocity time graph, because in the velocity time graph review, is there any point in like extending the x-axis to the left hand side? Since it cannot be negative.
Okay, extending that side there to that to give space there. Because the graph. Because we are working with Cartesian plane. And every Cartesian plane must have a positive abscissa, negative abscissa, positive ordinate, negative ordinate to be a Cartesian plane. So sometimes they have to just be there in your presentation. They have to just be there in your presentation. Should I tell you something? One of the most important things when it comes to submitting data, scientific data, is you should not attempt to submit the data to favor your results. If not, even if you do not arrange anything, they will tell you that you falsified it. Here it is axis. Many of you, when you submit your graph, that's why you'll be seeing those things on top. It's the truth. If there's a reason why, do you know, have you ever asked yourself a question? Why is that the examiner used to say you must use 2/3 of your graph? It's harder to lie when there's space. That's the reason. If they didn't do that, you can constrict all the space, and the examiner will now suffer it straight eyes to be tracing. 2/3, if you're not using 2/3, you're not marking it. You understand? It's harder to lie in empty space. You are clear, they will see you. So they want to put themselves in what we call a 360 Q zone. They can easily see your errors fast. That's what they just do. Oh, when you hear ordinate is the direction of the vector that moves to the y-axis. Do you understand? Oh, ordinate is just y-axis. Do you know somebody asked me one day? I don't know how to do it. Person said, is y-axis always vertical? I said, it's y-axis always vertical. Because there's a way you see. That's what I said. That's what I said at the beginning. That your perspective or view of physics is not what matters. It's the inertial reference frame. And that was what Albert Einstein did. The first thing Albert Einstein ever did that he presented in the secondary school is to enable us to understand that keep your perspective, utilize inertial reference frame. That's the only place science we agree. Before that statement, and you use it to scientists that will speak the same language. Everybody is saying different things. Everybody is saying different things. Why do you need my opinion? Okay, what is why is it? Okay, this is it. This is it. That y-axis and x-axis is plane dependent. Do you understand what I mean? Plane dependent. For instance, you know that the earth is rotating. The earth is rotating. And you are standing here. So let's imagine that you were here at a point in time during the rotation. based on your view of where you are, you replace let's say you place a directory here, and the directory is showing you the 4 cardinal points. Abi, what we need to be here? Not here is what? Here is what? Here is what? By the time this thing rotates, just the earth just does what God told it to do. The rotation. When it rotates more, I sure that when this point is now here, that you're not supposed to be facing up. I don't know if you get what I'm saying. There's a point in time that this thing you pointed north will now be looking like it is now here. It's now pointing west. There will be a time this north, by the time the rotation has taken 180, this north will now be facing me south. So it's just on Google. It's on Google. And because the person was submitted to it is very clear on Google. Yes.
Just one more question. Question 1. The decimal velocity is 12.01 meter per second. The second question. The viscosity is 1,416.4 pascal per second. And I need to find the digits.
Radius of what?
The last question.
Determine the radius. Just this, push through this, one do this, and then this. Determine the radius of this bed. So what's hindering you now? Is there a missing parameter?
No, sir.
So what's hindering you? You just have beef in getting it. What formula is it? The one I gave. Okay, the one I gave. The two densities are there. Is there G? G is there obvious.
G is constant.
Is there what do you call it?
There's viscosity, there's terminal velocity.
What else? So why are you not getting it? I don't get it. Do you have something? Is there any statement that shows that you're not correct about when you solve it? You have not solved it yet. You get it if you solve it now. Just make out some type of formula. Did somebody clean that pi r is pi r square? It's pi r square area of the circle multiplied by g. Even this multiplied by g. Yes.
Perhaps within the previous answer, I don't correct.
You adjust it by a factor of 1 hour. So between physics and chemistry, what do you prefer?
Physics.
Why?
Because physics is what I was saying.
So you're not saying chemistry.
Chemistry, they're just telling you that things are happening inside.
You prefer chemistry? I don't know why it's like that for Nigerian students. Majority of students, what's their favorite? Just like physics. Physics. Truly, physics is relatable. Who can differentiate between your gravitational law and the universal gravitational law? Why is that? Who can differentiate between gravitational law and universal gravitational law?
Because at the reference to the last question, 7.4 times 10 is power minus 4 meters.
You think it's not correct?
It's correct.
Because that's one of the things. You said the object must be very small.
So what was your question?
The difference between gravitational, that your normal gravitational law that says that anything that goes up and your universal gravitational law. Newton's law of universal gravitation.
Gravitational law is the one versus the gravitational repulsion. And gravitational law just says that gravity acts on every object that is within the x-axis.
But universal gravitational law, that's not what it's saying.
That's universal gravitational law.
Yes,
Says it.
state it.
It says that under the x position.
You are lying. You lied. You started with, that's the fallacy.
No.
You lied. I don't know if you did that intentionally to satisfy your argument. You lied.
It's not like
Under the earth, if you can bring out anywhere you go to the earth, I'll dash the laptop. Any article where you do that. You want to go and create the article.
You gave me
Bring it out now, just type it. It's not possible. That's why they call it universal gravitation. It's called universal gravitation because it works even outside the earth. That constant G, when you're solving problems of mass, you don't just use that constant G there. Is that law confinement is very little.
So, sir, let's say that the earth gravitational law works only within the earth.
Yes.
And the universal gravitational law works within the example 9 planets, Mars,
Yes.
Jupiter, and the rest.
And I feel the universal gravitational law is a more general and acceptable law because that law, let me go to that part, that law explains the reason why it is not proper for you to stand beside something you don't want to fall on. Let me just say that.
I feel like a mountain top.
Okay. That's what it's thinking. That's what it's thinking.
Okay. Let's go to it, sir. I'm happy with that.
The high tension wire. Let us talk about the controversy about it.
Okay, sir.
Is it true that high tension, when it cuts and it touch the floor, that everybody in that area will suffer some level of injury, some level of casualties? Is it true? Okay, so what do you have to say to people that believe those things? Well, there are plenty of.
It's not true because if we are inside this building now and any tension wire cuts, I feel like the majority will be within people that are actually within the axis of the pole or sphere of the pole. The ones where I said, I know that the casualties will not travel and reach them.
Okay. Can high tension wire kill somebody when it is not in an altitude?
Okay.
Like, if you climb up and you touch the wire, you obviously kill the person. But now, the one I want to ask, if that wire falls on the floor, does it still have that same damaging effect? That the lethality of that wire, does it still remain unchanged?
Is wire falling on the floor or on the person?
Fell on the person on the floor is no longer at that height. You know how far it is. Why did they call that? Why did they call it high tension?
It doesn't have the same reason because at the ground level, the
Pressure.
yes has reduced because at the bottom pressure increases on the top and not on the bottom. No, pressure is down, but down, and now supposed to ground. So I feel like on supposed to ground, the lethality will not be the same as that of and the highest too.
So the people that said that they told me, I've heard people that said things. I think landed, and they saw the thing moving like lightning. What do you have to say about that one?
I've never seen so.
Because me, I've seen high tension for.
So what was the result?
I don't see anything. Nobody. It was just like a regular wire that fell on the floor. So do you think you should experiment it? No, not saying anything happened. Let's go and touch.
So please, let's move back to fluid dynamics.
What's interesting in the fluid dynamics? You continue for the radius of ball. And that tension for. Even if normal wire touch water on the floor, what did it show you? Jesus. Wait, when somebody gets exposed to an electrical discharge, what kills the person? Current or voltage? Or something else? Who is the killer? Is it current or voltage? Who is the killer? You can meet both. I want to hear your point of view. And the only way you can get some answers is to train your inductive thinking. Train your deductive thinking. You understand? Look at what you have. From what you have, do something concrete. For example, now, if you really know what current is and know what potential difference is, then you'll be able to make a more scientific guess. You understand? Scientific guesses are not random. They're not like random statements. They are statements of high probabilities. Whether they did or not. So which one do you think kills? And also, when somebody falls from the height, what kills the person? Is it force or impulse? Or impulse?
Impact was the person and the
Okay. So this other one now. When they do what? I didn't hear you. I like that question. Say it out. Let's
I say that when there is no current, can they be voltage?
When there is no current, can they be voltage? So we're expected to hear why you feel so. We're expected to hear more.
There's voltage. Because current is the circuit.
What? Talk to us.
I'm talking to you, sir.
No, still your mind, your own point of view. Let's reason.
When there's no current, there's still voltage passing through a circuit. Because
when there's no current, there's still voltage. Okay.
the current is low.
No, said when there is no current.
When there is no current, there's no voltage.
So when there is no current, there's no voltage.
Yes.
You're confident.
Yes, sir.
Why?
Because when current is not passing through a circuit, there's no voltage. When there's no current, the circuit is closed.
Okay.
And according to the junction,
Junction,
nodal rule,
yes.
nodal rule, there has to be a level of current entering to be a level of current leaving. So when the current is closed, there's no voltage because the closed circuit, the total amount of potential difference here equals to 0.
That means there's no current in the circuit.
You said that there is no current. When there is no current.
No, ask a question when
I said that there is no current. there's no like nothing at all.
If there is no current, if it's a switch, if there is no current, the switch is basically up, it's turned off, it's closed. And in a closed circuit, there is no potential difference. So when there is no current, there is no voltage. That is my point of view.
What's voltage? That's potential difference. Right? So what's the function of potential difference? Yes, what's the function of potential difference?
Water is the current. Like, how fast water direction? What is causing water to go fast or slow? So high voltage, like,
So
Yeah.
let us ask the person that asked the question her point of view.
Question has landed with your cup. Drink from your cup.
But I believe that there is no current.
Why? They like to say that was our. But the other things that we doing, tell us why now.
Basically, there's no current. How would you go there show what so tell you, please help us answer.
Okay. Potential difference is the driving force, is the drive to the flow of current. In the very similitude of how heat, how temperature is the drive to heat. If there is high temperature change between two surfaces, heat will flow easily. That's the same way if there is a large potential difference between two surfaces at voltage, current will flow easily. Now, potential difference is what opens you to the danger of what current does. So if there is no voltage, current will not flow. What you will have is static electricity. Do you understand?
So sir, with your boss, were right.
I don't think anyone said anything.
I was saying
I've forgotten your point of view. Okay. Okay, true. Oh, you made points. Everybody made points. Everybody made their points.
so sir, in the
Yeah.
the person you asked about what kills, if it's the current or the voltage, basically the current that kills because there has to be a high amount of voltage for current to burst.
Let me ask you a question. When somebody has HIV, listen to this. When somebody has HIV, what kills the person? When somebody gets exposed to HIV, right? The person later develops a syndrome.
AIDS.
Yes, it develops a syndrome. You know what a syndrome is, Abi? A syndrome is a spectrum of diseases that always manifest as opportunistic infections. I get you now. So the point is, listen up. The point is, who killed the person that died from the HIV? Are you sure that it was the AIDS or the HIV who opened the door to AIDS?
Because you can live with HIV, even if you probably
Okay, but let us imagine a situation where you can't take care of because that's the same thing happening with current and voltage. Anything that makes a particular voltage enter into you, right? It opens you to only if you guys can understand how mad it is. See, I just need you to stay in a place from your head where at your head and your leg, you just have a great voltage drop. Let me tell you what might even kill you. You don't need the current. All the current, the person, all the current in your body, natural current, the neurons, is those ones that first of all will show you. But the first of all disappear. You have to stop, cease instantly. The person has to stop instantly.
Okay. Are there any drawbacks to buying magic?
Yeah.
No. I don't think we are.
You can challenge anything. If you really want to challenge anything, you can actually challenge anything. It's the truth now.
So why do you conclude that a velocity cannot be negative?
Who can go
You always say that you cannot be a negative velocity.
there? Hey, Jesus. Wait, do you know I can sue you?
Sorry.
Do you know I can sue you?
So I'm not being
Because you won't have an evidence for that, and I know I've never said such. You understand? You can't. You don't have any evidence.
Sir,
And my evidence will just be my authority book. I just need to bring it out and show them what I know. This is what I know about velocity. If it's not there that what you said is the case.
okay, so sir, what does negative velocity mean?
It exists now. Negative velocity means velocity in the negative direction.
So basically like this one.
If we have accepted now that this is our x-axis and this positive x and negative x, an object moving like this is moving with negative velocity. Do you understand? It's speed that we don't need to start talking about the direction.
So we are talking about Poiseuille's equation.
Poiseuille.
Yes, talking about volume flow rate.
Mm-hmm.
The volume flow rate is basically the
It's like fluid dynamics is your best. The way you are just always going to that fluid dynamics is a nice thing. Yeah, continue.
volume flow rate is basically the amount of sometimes they use cube.
Yes.
So when you're putting because they are telling you that the rate of flow of the liquid is then proportional to the first power of the radius, the change in pressure, and the inverse of the length.
Yes.
So are you saying that when the length is shorter, when it's a short length, like maybe a small square, the pressure there, as when the length is reduced, the pressure there will be increased.
Yes.
Right.
Because given that continuity is a thing, and bulk flow rate will be maintained. It is normal for us to think of it as that. I said that you asked the question. Oh, yeah, what was the question? Let me see if you know what you're asking.
I said, if the length of the container, of the containing vessel is decreased, does that mean that the pressure will be increased?
No, you don't say length of container before.
I said that.
Okay. If the container itself.
Yes, that's the distance between the two ends of the container.
Yeah.
If it's decreased, that is a small square, does that mean that the pressure inside will be decreased?
Now let me say something. In pressure, fluid dynamics, the distance this we talk about most times is the cross-sectional, like if this is the wire, if this is something that's carrying the fluid, we are considering the distance of the opening. Do you understand what I'm saying? Not this one. This distance here does not have anything to do to us. It's only going to delay, it's only going to act as a delay to when the fluid will come out at the back end. You understand what I'm saying?
Yes, sir.
But this other one, the diameter, it's going to affect the pressure. In fact, that's the real cause of BP. When you hear that somebody is having blood pressure, the person's blood vessels are constricted. So imagine putting a small pipe in a tap that runs with high pressure, right? And reducing the diameter of the pipe. It's not very slim. You know that the pressure with which the water hitting the walls of the pipe can rupture it.
Yes.
That's it.
So can we say that that relates to postulate of not postulate of refined postulate of
Yeah, don't say something. This is for you to drop. I should say what's your mind. Am I in your mind?
And
I will say that you know the
I don't know why I just feel that this girl will write things that will confuse the future. Or, you know, we are still complaining about the ones that people are waiting for us. We are waiting you. Hope you have started writing your books. Better start. Most times, those basic ways you understood things might just be your language, might just be the clarity you need later. Because I won't even lie, my secondary school physics textbook was my best book I ever used in my life till I even finished school. I loved it. Seriously. It kept on revealing many things to me in med school. Like every single thing, Francis law, it was always reappearing. It was always reappearing, It was a nice book years back. So sometimes you might just have one passion, you might have one kind of connection with one of the books. I can tell you. Just keep them, including the ones that you missed the answer. Keep them. Document your failures.
yeah. Then what talking about X-rays? X-rays they are chargeless and they are mass.
Yes.
So do you think that there is a state where X-ray will be kept in a field and it will be deflected?
That's why I said I knew you have plenty of things to write in future. Because you look like somebody who soon do it. X-rays will not be with that, like you can keep X-ray like laptop here. I mean,
Yes, and it will be deflected by either a gravitational field, magnetic field, or electric field.
sincerely, I don't believe in possibilities, but that one, I don't know. I don't feel it can. It defies the identity of it.
Where's the identity of X-ray?
It defies the identity.
Like it goes against the definition of X-ray.
Not like the identity is what you mentioned.
Yes,
Massless.
chargeless and massless.
Eh?
Okay. Okay. So I said that is an impossibility that cannot become possible.
That's not what I said. I just said I don't believe in possibilities. But that one, I'm 100% sure if such a thing happens, they will change its name. They will now tell you that there are different types of radiation and probably add that one as a new radiation instead of it an X-ray. It will cause a lot of conflicts now. It will cause a lot of conflicts.
Okay, when we're talking about Newton's law of cooling, there are two temperature differences. What are the temperature differences? Is it between the body and the environment? Two bodies in contact.
You said there are two temperature differences.
Like if you are stating the law,
And
there
there
is
are
a temperature difference between two temperatures. So can we say that the temperature difference is as a result of the body and the environment?
Yes.
Two bodies in contact.
Yes.
Or two bodies and an environment.
Two bodies.
And an environment. If the two bodies are in thermal equilibrium.
The two bodies in contact. Because eventually, if the container was opened, you are not allowed to use the empty walls in the container. You use the surface of the fluid exposed and the surface of the fluid in contact with the environment. And the environment in this case now is the inner wall of the container. That's the immediate environment of that system.
So it's two bodies in contact.
Yeah.
But then that goes against the law because according to the law, it states that it is between a body and the environment. The temperature difference of the body and the environment.
What have you said already? Is that what I was saying?
See, I gave you a body and the environment, two bodies in contact, two bodies and the environment.
Your environment, what do you think is an environment?
It's a body.
The environment is every other constituent of your surrounding aside you.
Aside you.
So this water now, the bottle here is part of it, the environment of the water. That's the immediate environment. Don't you know? Should be in physics, thermal physics, we say that we have system and surroundings. The system is the site of the reaction. The surrounding is every other thing aside from it. The immediate surrounding is the container. If you are solving questions from this aspect you mentioned, go and pick questions, you see that it is usually because fluids are kept.
So we're looking at the temperature difference between, if we are using this bottle as an instance, what kind of temperature difference between the water and the containing vessel which is the ever bottle?
It's superficial, we call it superficial contact.
Okay. Does that relate to the an apparent expansivity too?
No. During an apparent expansivity is a different thing entirely now.
Okay. Okay. Atom machine. There are two masses in a normal simple atom. In an atom machine, there are two masses. There is M1 and M2. If M1 is less than M2, with the tension, M1 is less than M2, will the tension in M1 be greater than the weight, or the weight be greater than the tension?
If M1 is what?
Less than M2. Will the tension be greater than the weight, or the weight be greater than the tension?
So, if you say M1 is less than M2, you are trying to say that M2 is greater than M1, right?
Yes.
So if M2 is greater than M1, it means that the tension around M1 will not be sufficient to lift. This tension around M2 will not be sufficient to lift M2, because it's great.
The tension around M1 will not be sufficient to.
The tension around M2, you said we've concluded already that M2 is greater than M1. Good. Meaning that M2's weight is greater than the tension in the rope. That's because a downward motion around M2 and an upward motion around M1.
So in M1 you have tension greater than weight, and in M2 you have weight greater than tension.
Yes, that's to describe the acceleration.
What if M1 was greater than M2? You'll be having weight greater than tension in M1 and tension greater than weight in M2.
The coronary, yes.
Okay.
You know there's a wahala. You work on that issues.
Now looking at elements of modern physics. Is there an instance where you have two wavelengths and they tell you to equate the two wavelengths to find, maybe they are giving the wavelength of one, or maybe a hydrogen atom, and they are giving the wavelength of maybe uranium? Is there and we are giving the energy difference for the both of them? How do you find the wavelength of uranium?
Of uranium?
Yes, you are giving two. You are giving two things.
What thing I'm hearing you now? I'm hearing you actually, I was talking, not talking from sleep. What thing you?
I'm not sleepy. I'm happy.
How did we get to uranium from wavelength?
People just assume that it's a body.
I can't be in your assumption.
Why?
You used to think I'm your head. God. You didn't even welcome me and tell me about now. I want to assume. Follow me. In this assumption. What is your assumption?
My assumption. We're using hydrogen and helium.
How can they even never be in the same place?
Why can they not be in the same place?
Are you disrespectful? God, look at that they shake it. I don't want them to be in the same place. You will be the first not to be there. Random and nitrogen. You will be the first not to be there.
Let's use two bodies. Body A and
Who is body A?
you are body A.
No, I can't sit in that position.
So who will be body
I'm not an alphabet.
Yeah, body A, body H, body Henry.
Be serious, this is what you do.
I'm
Use
serious.
uranium and who?
I
Use uranium and yourself. Let us move forward.
I should use.
Uranium and you.
No, uranium and Dr. Henry are together, and you have a wavelength, and uranium wavelength is unknown, but we're giving the energy difference between you have
Okay.
N1 and N2 and you have N1 and N2. Is there a way we can equate the two equations of private to
You want to equate the primordium of the end of Hiroshima to human being flesh. Say you want to equate it. What are you equating, right?
let's use two human beings.
Then say I want to use human being. Mention name.
I want to use human beings.
Uh-huh.
Dr. Kachi and Chidima.
Okay.
Okay. I think you asked the question in our last month. That's why.
Okay.
When we were told to find the wavelength of the second. Yes.
Okay.
Is there a way you can find it by equating the both of them with both equations?
Okay, what we were talking about was coherent waves as well as superpositioning of waves. They were trying to utilize what we call path difference to obtain the nature of superpositioning. We want to know if the interference is going to be constructive or destructive, utilizing what do you call it? Phase differences or path numbers.
Okay.
But I don't know, like, where are we going to with them? I'm trying to understand where is the end point, because like this now, the two waves, once one is a whole number of a wavelength, it forms a constructive interference.
Okay. Constructive, that's the equation of the bigger. That's going to go.
Yes, formation of a larger amplitude.
Okay. Yeah, exchange junction.
This guy is like that, just bothering you since. You were in our electrostatic class. Let me ask you that question. Where were you with this new hair? When did we do it? We meet in class. In the class we talk this one. Thank God you haven't exposed yourself. We meet in class.
We're talking about vector resolution on that topic.
Yes.
You gave me an example of a topic that we cannot resolve, which I do not still support.
Example of a topic that we cannot
We cannot apply vector resolution with the activity. So, what other topics do you think you can apply vector resolution?
I think we can apply vector resolution.
What other topics can we apply vector resolution?
There are plenty in almost everything, except from that one I mentioned.
Apart from the activity.
Yes. Can you mention another one that they are not applying vector? You will see. Actually, they apply vector. During the formation of bremsstrahlung, is it not the force that the concentrated force around the nucleus that causes a digression, a deflection of the vector force?
Okay.
Vectors are there now.
What does atomic structure.
You saw today, when, is it today or yesterday, when we came to the conclusion that the electrostatic force that acted upward was going to balance gravitational force downward, and that's how we were able to get the charge of the electron. Vectors play a role there.
So right now, how about semiconductors?
Are you not saying that? Vectors play a role in semiconductors. During the conduction process, no be current dey flow. It's when that flows now, they have the organized way they will flow.
So sir, I always have questions under mathematics, under instantaneous and Platonian velocity and acceleration.
Mr. Ade. Mr. Ade is the backup, is the one as the problem bank.
So please, supply us with problem. Sir, when you're going from a position vector to acceleration, you integrate or you differentiate.
I'm laughing. The fact that you mention position vector. I think we should just mention position.
Position to acceleration.
Okay. So you are going to differentiate,
Wait,
and it's not once.
twice.
The first differentiation is going to give you the velocity, the second one will give you the acceleration.
So we having the square the square x over the square. Square let me work the two square. So let's solve the question.
I'm not about to sleep now, but I'm with you.
Do you have other drawbacks to topics we've covered in physics?
Drawbacks. The only drawback that I can see is the drawback of the problem. What's it? Drawback. I took my mind. Okay, that's the only drawback. And that's the drawback.
Sorry, sir. Actually, I was on Google today and I realized that our traffic lights, they use housing circuits. So I don't know if you can explain that one.
Housing sections.
Housing circuits.
Okay.
So I don't know if you can explain that.
Well, I've not really understood what you mean by housing section. Is it like you're talking about the system of their connection, maybe, or you mean like the tap lights from normal house?
So like,
Because I'm not surprised that Nigeria is tapping lights.
so like a resistor capacitor circuit.
Okay.
Something like to time the time difference from where to here.
That is down, I believe. I don't trust it. I've not checked it before. As I said, I believe. You can come tomorrow and tell me around and tell me, true. I don't believe again. I believe it's possible. It makes it. It doesn't make sense.
Let's talk about the postulates of the board.
Yeah. And I've started it now. On it. What is meant by resistance?
Let's talk about the postulates of Rutherford's model of an atom.
Okay.
So what are the postulates of the Rutherford model of an atom?
Okay, help us with. So the postulates are very simple, right? Do you want Rutherford or Niels Bohr? Let me be clear. Hello. Rutherford or Niels, because Rutherford's postulates, they are nothing serious. Like, those are the modifications of John Dalton. Isotopy, expenses of isotopy, and all those Mass
Charge to
visible.
mass ratio.
Yeah,
We have charge to mass ratio there.
that's Robertson Leakan. Yeah.
Okay, so what are the postulates to Rutherford Milliman?
So Rutherford believes the name of his model is called the planetary model. So he believes that the atom mimics the celestial configuration. He believes that the atom is made up of a central heavy nucleus with electrons orbiting around them, the very similitude of how planets orbit around the sun. You get, as explained by Kepler. So that was his ideology, but his postulate, or it wasn't yet a postulate, his description of an atom, his model, had a lot of limitation. Because it could not explain the quantum property of the orbital.
Those are the drawbacks.
Yes. It could not explain nuclear stability. It could not explain the distribution of protons. You knew the protons in the atom, but the knowledge of it being concentrated in the nucleus was not the thing. You get it? So it was now his students, Des Bohr, that worked on his model. People make mistake even with his model. We are writing IGC SC exam, and they ask you for a model, and you can't drop planetary. They will tell you are wrong. They will tell you that planetary is for Des Bohr and nuclear is for him.
Nuclear.
Nuclear. But here in Nigeria, nuclear is for both of them, planetary for both of them. Anyone you write books.
I will say that his postulates, they relate with Kepler's laws.
Yes, his model was about planets. He was simulating the atom with planets. So it looked more like that. I feel like that's going to be a geographer.
So when we talk about the drawbacks, you have that he could not properly explain Zeeman's effect. What do they mean by Zeeman's effect?
You see, how nuclear charges and effective nuclear charges contribute to shielding and contribute to orientation of neutron in the nucleus to prevent the disintegration of the nucleus as a result of repulsion of two adjacent nucleus. It's a thing. We know that you can't keep two repulsing things in the same room. But that was what his model was giving to us, that protons were all residing in the same confinement. We couldn't disagree much with other people that already said electrons are scattered around, because they just have to be scattered around. Electrons are negative charged particles, so you can't keep two of them in the same place. Many subatomic presentations came with those ones, saying that they have to stay in opposite spin so that they don't feel the effect. But without the millions, and I just know that they're in the nucleus. So the question we're asking is, how were you able to achieve, like, how do you feel an atom will be stable having repulsive candidates? For example, the word candidates, even in just particles. But repulsive candidates there at the same time, when they repulse and get the nucleus burst or destroy the walls. So that's what we mean by Zeeman's effect.
Another thing was that it could only explain the neutron in hydrogen atom. So are you saying that Rutherford atom could not work?
I don't know. I think I don't think you got it. You get the concept of the. It's Niels Bohr that his model was on the basis of hydrogen atom. So yes, so Erwin Schrödinger now came on board to now bring in the electron cloud model and now put things in place that satisfies other orbitals. That's why Bohr's radius is only peculiar to the hydrogen spectrum, not that spectrum.
Okay, then there's another possibility that I could not explain fine line spectrum.
Okay.
What does that mean?
Line spectrum.
Yes.
So first thing first, a spectrum is an arrangement of frequencies in an orderly manner. So a light spectrum is a form of discontinuous spectrum. In a light spectrum, two things has possibly occurred, right? Someone has stolen the light, or someone brought the light. But let me put it in the context of what it is. A light spectrum, by physical presentation, is a spectrum that contains what? It contains dark backgrounds with what? With bright lines, or bright lines, or dark lines in bright background. Each of these two things are a result or consequences of emission spectrum when electrons move from high orbital level and fall to lower orbital level, losing energy in form of photon, or when they form absorption spectrum when they are doing what? Exciting from lower orbital level to higher orbital level. And we know what they need to do that. They need to absorb energy, and they absorb it in form of light. And the region of space, the axis where they do that absorption, becomes dark instantly. So darkness is the absence of light.
Okay. Okay. Now, we are talking about thermodynamics. I saw somewhere that they said that the coefficient of performance, the
Yes, I'm with you. COP.
yes, and the heat engine.
And in what?
And heat engine.
Okay.
The CC is not the same thing for one of them. One of them is heat absorb and the other is heat discarded. Which of them is the heat absorb and heat?
It depends on the reservoir that engine uses. Some engines have two-way reservoir. You understand? Those two-way reservoir may have that C and CH to expel hot water or hot fluids. You understand? They keep those things in order to make sure that the system is not overheating. You get it? So a system that only has ATC is serving as a reservoir to eliminate what kind of water? To eliminate heat. I don't know if you know what I'm saying. They are there to eliminate it. Everything is working for to bring everything to a balance, to an appreciable balance.
Okay. Now, yesterday we talked about counterbalance spectroscopy.
Yes.
What can we say today about Fraunhofer's line?
Okay, Fraunhofer's lines, right? Those are the lines you find from your spectral series when you're moving from Lyman to wherever you want to get to, the P-Fund, Humphrey. But those lines are the line of emission. They are the line that demonstrates loss of energy from transition electrons from higher orbitals to lower orbitals. And they are a number in every series, controlled by a function. You understand? For example, if you are moving from the P5 to the first orbital within the Lyman series, it will be made up of how many Fraunhofer lines? You have 5 Fraunhofer lines. So the Fraunhofer lines are just there to describe, they are imaginary lines, they're not real. Radiation transition. No, not radiation transition, electron transition. Yes.
So, we have the Newton's laws.
Newton.
Yes. We have 3 laws.
No, he has more than 3 laws.
Motion.
Okay.
Are there limitations to these laws of motion?
Yeah. I don't think I'm the best person to contradict to Newton. I don't think. Maybe that kind of question is those kind of Galileo, and all those ones. They're the best person to argue this kind of thing. So, you know what people don't know is people like Newton, they're the fathers of physics. Even if they come today and say something that is not true, once they can prove it, all of us are doing, that is what you must write to your exam. That becomes our truth. That's why, personally, I'm a nihilistic scientist. I really don't believe in the science we do. I understand it. I see some of them working, but I feel there are other things controlling these workings. Like, it's just a matter of us removing some of those things and they won't work again. If not, I don't feel laws should have confinement. They should just be telling us, do this and this what will happen. Don't each one is giving that this one is kept constant. Let everything be in life. In real life, is it possible to keep some things constant? to tell you keep temperature constant.
Sir, in a car accident, when you have a collision, an airbag comes out.
Yes.
What can you say is causing that airbag to resist the infliction of injuries or bodily harm on those passengers?
Impulse. The contact the person would have used to strike the dashboard would have been in a short period of time, and it's the duration of time to the exposure of the impact that kills the person. That's the same reason why somebody can fall from the top of a roof. You just want them to put a soft landing. The person will die. Why? Because it increases the duration of the impact. But if that's not there, the impact will be in a short time, 0.04 seconds. You've made the impact. And that shock is what kills the person. So my own question, when an unmovable object collides with an unstoppable body, what will happen?
When an unmovable object
Collides
collides with a moving
with an
object,
unstoppable.
like a constantly moving object.
I know you understand what I'm saying. You are trying to build an answer, and I want to see you build an answer without compromising my statement. We have an unmovable object, and an unstoppable object collided with it. What will happen that will balance the situation of not begging the statement? By begging the statement, I don't want to hear the unmovable will scatter, because it is actually unmovable. It's not supposed to scatter. None of these components should move.
I don't understand your last question.
You understand?
I don't understand.
You are buying yourself to gain time.
No.
I will repeat. An unmovable object is confined in the belief that even its particles can't leave his body because it's unmovable. So, what will happen when an unstoppable object collides with an unmovable object?
A practical example of an unmovable object, you can have doors hand.
No, that's not true. You said no, it's not true.
Like when it's not tall, like carrying
When it's not
tall.
tall,
Yes, tall's hammer.
Thor's hammer is movable because Thor moves it.
When it's not tall, let's not assume.
No, you can't. That's the first bottom line. You can't go to that kind of argument. No, I will tell you that Thor moves the hammer. That hammer is movable.
Let's assume Thor is dead and his hammer is dead.
Then there is somebody like Thor somewhere with the hammer too. Because last time I checked, Captain America moved the hammer. The hammer is a normal hammer now. People use it to hit nails. How do you have hammer?
That's very practical example.
Answer my question.
What do you see?
When an unmovable object collides, unstoppable object collides with an unmovable object, build an event that satisfies the outcome. You already know the answer. You asked me, is your movable object a static object? For the fact that it is unmovable, that means you can't find it in a moving state. It is static.
The unstoppable object will have to move, or will have to roll back to the direction that it was coming from when we collided with the unstoppable object.
Just what I said. I think what it's trying to say is it will rebound.
Yes, it will record, like it will hit it and bounce back. Basically,
But we know within ourselves that during rebound events, there's a period of stop.
yes.
So that defies what it's saying too. Do you know what I believe? That is why the reason why we find able to answer this is because those two things don't exist.
Yes, because if we can also say that if there are different masses, the mass of the unstoppable is smaller than the mass of the unmovable. The unstoppable, when it strikes the unmovable that has a higher mass, it's going to break.
Who will break?
The unstoppable now, it's small. It is smaller.
When it break, then what happens? It will stop.
Then it forms a hole in the unmovable.
Now you are begging the statement. I refuse to be in this kind of biased stuff. You are already spoiling the identity of the two.
Then we also have another instance where the unmovable
Sorry,
is.
I say the instance I give is not sufficient. Or you just need to reduce the difficulty in the instance by creating instance. It's that simple. So what will happen?
cannot say that you cannot just say it will bounce back because if it bounce back, since it's unmovable, it will come back again to hit the unstoppable. Since it's unstoppable, it will come back again to hit unmovable. So it's just a constant state of going and coming, going and coming, going and coming. So maybe both of them break.
Break. This is what you said at the end.
Break.
That means if it breaks, that means the unmovable is not movable. Breaks.
Just be a constant motion of the both of them going to and fro.
My second question. In our real awakened world, right, and in our dream unconscious world, every event can occur. So how do we prove to ourselves right now that we are not dreaming? Like you know you're awake.
So you are awake.
So prove it. Because you are conscious. Do you know that in your dream, the proof that you are conscious is that you used to run away from danger? In your dream, the proof that you are conscious in your dream too is the fact that you used to run away from danger in your dream. That shows that you are conscious there too. Sometimes you wake up with the consciousness of your dream and bring it to the reality of your awake. Out of it, where your unconscious dream world is now in similitude with. That's a synchronicity.
Okay. I don't think there's any way we can put them on not dreaming now because you could be dreaming now.
That's the problem. That's the problem.
And we'll be doing this of our dreams. That's my answer.
Please don't reason up his hand. We're waiting for kick-off. Kick-off.
So I should use the question and go.
One, two, three, do. Just start. Okay. Yeah. So, all right. It's been a long night. So, we're going to be doing something, and I'll be running through certain theorems in physics, relatable theorems, very relatable theorems, that will bring out the complexity, the complexity in those theorems and reveal how simple they can be. No. So I'll start by saying that physics are of different branches. And those branches also have their branches. Physics as a course can be broken down into the following. And from each of the following, I want to build a firm foundation that can take us into the following. So what are they? The most basic and foundational form of physics is what? Is mechanics. Because when a child is born, the child first learns how to move. When the child is born, the child first learns how to do what? How to move. That's the same reason why when you start up physics, they first teach you about the physics of motion, physics of movements. Just to get acquainted to it. Then after the physics of mechanics, the next thing I want to introduce you to is one of the most greatest influence of your environment, which is what? Heat. Temperature. That was the first thing you got exposed. That was the first thing you needed to learn how to adapt to. Yes. Because when a child leaves, when a child leaves the womb, I get it. One of the things that happens is that what? There is this huge temperature difference. I guess you know, there's this temperature difference that does what? That the baby is not just used to and starts growing to get used to. And that is why the next aspect we'll see is thermal physics. From the thermal physics, this child starts growing and starts getting used to seeing the periodic side of life. How life starts throwing tantrums to people he knows, not him immediately. And he starts seeing that everything is just going up, down, and then he realizes that life is just like a what? Like a wave. After a period of time, he understands the importance of power. He observes the importance of power. And he sees that power is inextricable from a particular source called electricity. That's where we will now build him in to the concept of electricity. Electricity. From the concept of electricity, further push, and he starts learning to get attracted to events. He started learning to make decisions on what to repel. That is when you come across concepts like magnetism. So physics is like the rundown of a person's lifetime. Yes. And then from there, the real truths just pound on his eyes and find out that there is a lot to what he has been seeing. And that's when he sees what we call the modern physics. So everything just looks like a normal life pattern. We are going to build it from here to here. At the centric region of information of this first idea is what? Is kinematics and what? Dynamics. How broad is kinematics and dynamics? They span through the different states of matter. We have kinematics of gases. When we talk about the kinematics of gases, we are talking about what? Thermodynamics. We have the kinematics of fluids. We have the kinematics of solid state materials. True of us. So every single thing about mechanics is kinematics and dynamics. And that's where we're starting from. When we hear the word kinematics, what does it talk about?
The motion of the body without actually talking about positive motion.
It talks about exactly what she said. Change in position only. It's teaching us about positional changes, and it doesn't want us to concern ourselves with what causes those changes. And when we get to dynamics, we begin to build inquiry into a world of cause and effect. A world of cause and effect, a world built in the ideology of determinism. We want to now understand why people, objects move. The hardest thing to understand and accept is why people change. And as physicists, we already understand that everything changed is as a result of a force, right? And a force is anything that can drive an object. A force don't only drive an object, force drives idea. Well, because we are doing physics, we are subjecting it to what is concrete. We won't subject it to what is abstract. Yes, so dynamics, that is objective. So let's come here and start from here. The most fundamental part of kinematics is position. Position. I get what I'm saying now. The position we are is the fundamental part of. And the first important thing about self-awareness is knowing where we stand. And if we want to define position, position is simply the what? It's simply the point coordinate of an object in space. But space is too big for us to study. We scientists now define that we are going to limit this space to what we can relate with. A three-dimensional being cannot understand a three-dimensional motion. So that's why we work with two-dimensional planes, the Cartesian plane. The X and Y axis. Thank you very much. So every object is located within the point coordinates of the Cartesian plane. That's what I'm saying. If your position is unknown, delivery of items becomes difficult. Like look at, for example, now. You have to make yourself known. Declare your position for items to get to you. But items getting to you don't mean that they're only good items. Let me explain what I mean. Trajectory in real life. I get to now. Trajectory is position dependent. Do you know that? Let me not mention any country. But if you have a group of people who intend to attack another group of people, the first thing they want to know is your position. Because that's the most fundamental thing about movement. If I'm going to make a good move on the person, I need to understand the position of that person, how that person changes position. So we understand and interpret position as scientists, we interpret position and core position as point coordinates. Everybody in the universe, we see them as a point. We see them as a what? Point. Now, you know I'm saying this to help you reorient your mind as far as you approach physics. If you continue to try to build the bigger picture, your head will become chaotic. You can't build the world on your head. But on paper, you can solve the problems. The world on paper. Why? Because every single thing is a point. And you know that in a point, you have lines, but they will still tell you that lines, points are what makes up points. But in a point, if you magnify a point, a single dot, you find that it's even still made up of it will look like a line. Do you understand? So everything is about what? How you view it. Good. But the question there is, knowing the person's position alone, is it enough? No. Why? Because nobody is sessile. Is there anybody that is sessile? Do you know sessile? Sorry. I think I would have used a more physics-related technology. Nobody is static. Sessile is a biological thing. Nobody is static. Is there anybody static? Everybody is moving. And when you move, for the fact that you change your position, we need to also know how to study the changes in position. Let me make a very easy sketch. This is a straight line. This is somebody here. Look at this. This is somebody here. And let's imagine that this person is in point 2. Right? And this is another point. Watch me. And this point, we call it point 7. It's like a graph. Point 2, maybe point 3, point 4, point 5, point 6, point 7. Right? If this point is called point A and here is called point B, and I tell you that Mr. Emeka, I'm sorry if there's anybody here named Emeka, There is no intention to use the name, it just came. Mr. Emeka moved from point A to point B. And I ask you, how many units of movement did Mr. Emeka execute? What will be the answer? 5 units of movement, right?
Yes, sir.
Good. How did you do that?
If you find the difference between the distance from point B to point A, that's simply the point B minus the point A.
Very-
5.
Very good. Now, how about a situation? How about we build a situation where we exist in this line, and now we are no longer along the x-axis. We now build something like this. Look at what I'm doing. This is point P, and this is point Q. Point P now, with the way this thing is looking, is not an x-axis line, true of us, and it's not a y. It looks like something happening between x and y. So that tells this point is on the 2,4 position. This one is on the 3,6 position. When you see things like this, you are already appreciating that that object is being given what kind of coordinate? A complete coordinate. The first thing written here is the x, and the next one is what? Y. This one written here is the x, and this one here is what? Y. If I ask you to tell me the distance of this person, there are 2 ways you could report it. You will tell me the distance this person made along the x-axis, right? And the distance the person made along the what? Y-axis. It's very, very simple. Look at this. I could as well just draw the graph like this and put origin here. The meaning of this place here means if I trace this side downwards to the x, this point will be what? 2. If I trace it to the left, that's the y-axis, this point will be point what? 4. If I trace this one to the x-axis, we expect it to be point what? And if I trace it to the y, we expect it to be point what here? If you look at it carefully, if I want to describe the motion of this person, I can easily tell you that this person moved how many units on the x-axis? How many units on the x-axis? 1 unit on the x-axis. This person moved from here to here, right? How many units was that on the y-axis? So if I want to describe this person's motion, I can easily say he moved 1 unit in the x-axis and what? 2 units in the y. So it means that the distance between this person forms this line which we call coordinate 1, 2. I don't know if we're speaking.
Yes, sir.
Please give me a short break. Sorry. I took them back ahead. So yes. So if you want to describe the motion of this person, you know that this person moved 1 unit right on the x-axis, and how many units? 2 in the x. So 2 in the y-axis. Very simple. That is how simple understanding motion is. We just have to be real. It's just that our brain has not been able to process keeping huge numbers in our head. So we are looking for a smarter way, a shorter cut, and stuff like that. But look at the smart way here. Look at this, everybody. Look at this. The whole of physics is bounded to this thing I'm about to do now. And once you know how to do it, you don't have a problem. If you are here and you hate physics, there's just one topic you need to learn, like triangles. Because it's upon triangles that we exist. Be it 3-dimensional beings, be it the fact that every aspect of people's life is still bounded by the number 3. This person that moved from here to here that you saw as a straight line, you agree with me that this thing here is controlled by 3 lines. This line, and finally which one? This line. Are we together here? And are we together here? Now, this is our 90 degree. This is here. Let's call it our angle. Now, from here to here, we said it's how many? 1. From here to here, we said it's how many? 2. If you want to know the length this person moved as a single something, as a single, all you need to know is what this line is relative to this and this. It brings you back to your primary school.
Yeah.
What is the name of that thing? Pythagoras theorem. Now, this is not what we want, because if I told you that Emeka moved 1,2, it was, what do you mean? But if I just tell you now, that the distance that place there moved was actually, look at this, 2, 1, and then you have this. How do you get this line, this longest line in this right angle triangle? You do what? You say this place is what? Hypotenuse. So we have the hypotenuse square equals to what? Opposite square plus adjacent square. True of us. True of us. Then hypotenuse square is equal to, what's our opposite here? 2, right? So I have 2 square. What's our adjacent? 1. So we're having hypotenuse square equals to what? 4 plus what? 1. Hypotenuse is therefore equals to what? Hypotenuse square is therefore equals to what? 5. Therefore, that hypotenuse line is the square root of what? 5. Meaning that this distance from here to here is a number that we call square root 5. Very simple. Very simple. It's that simple. No complexity. Now, let's bring it back to this. You have a position, you have a point coordinate, either now of the Cartesian plane. This position has enabled us to learn how to get what we call, because what we did now was not to get another coordinate. We got what we call a distance. We got what we call a what? Distance. And there are ways you can get this distance without having to draw triangle every time, draw triangle every time. I get it now. You know, that's what concerns the make things easier for you to do. For example, this same thing we did now, I had to draw this, and this. Once you can present me with the person's change in coordinates, oh, the person was at point P, in coordinate 2,4, and he moved to point Q, or coordinate 3,6. All I need to understand is, oh, what formula? That's where formula comes in. It's from physics to start using formula. All those ones are really matter. They are just called, I'll call those things relationships, parametric relationships. Do you know why? Because before you call something a formula, those things are actually real, correct, and they unique physical events. physical harmony. That's what you call it formula. If I make a formula now, even in chemistry, in the hospital, the people make from pharmacists, what they make is you that call it drugs. I mean, they call it a formula because there is a protocol they use to combine things in specific ratios and organize them together for the purpose of performing a specific function. You have the answer up. You have a question.
So are you saying that a formula was calculated when there's a law or a rule governing it?
Now, there must be a rule that governs makeup. That rule must be reproducible, generally accepted, tested, and don't trust me when it comes to testing, especially things that have to do with health. You pass through, we don't call it tests, you pass through trials, series of trials before approval. You understand? Because that one now, if it goes out to the market, before they will be able to get it back, the damage is done. But I'm keeping it real simple because it's physics we are doing. Those formulas are, and there are a series of arrangements that are organized mimicking events. You see the reason why I'm using events is simply time-bound occurrences, mimicking events. I get what I'm saying now. For example, I tell somebody that to calculate the speed of a person, divide the distance traveled with time. Is that a real thing? It's a realistic thing. If I tell you I want to know how fast this person drove, it's a very simple thing. What time did she leave? By 4. What time did she come back? By this. Given that there was no stop, she did not stop anywhere. She told you she went and came back. Your mindset now is you just went, it's 2 times you did this distance. She has calculated distance ahead and she divided it. You are fast, so our parents, the kind of science they used to do in their head. How is it that they used to tell you they are supposed to come back home at so time? It's not their essential. They are giving you this calculation based on how fast you walk. You understand? If you are a slow walker, they'll tell you that. Otherwise, did you balance somewhere based on? And the funny thing is that they even learn us too. Physically, they learn our physics. Even before we start learning our own physics. How? They know how fast we walk. So I remember my mom there, she tell me, don't go and send this boy. Before you come back, it's not going to ask you to bed, but before you will come back, it's going to stroll, the food is going to burn. So they studied everybody's physics. And that is what we call qualitative study. I know what I'm going to. Because some of you just feel that I can jump, I can leave that one, do those ones, and leave that one and do let me go into the physics thing. Those things they are doing makes them better scientists than us sometimes. It's just the truth. Because that thing they are doing, we call it in science, we call it precision. What do we call it? Precision. Precision. Without numerical data, without values, they are able to give qualitative report about what is expected. Right? And eventually, you now go and find data. You can then, when I mean data, I mean write things. You want to calculate. Wait, you can't tell me. How should you just tell me that I should just pack the result anyhow? Just look at it and look at the report and just put. And you find that you always work for them, but you try to learn this kind, use this continuous spoon for this continuous soup. That means this one I'm going to use 2 spoons. And you do it and spoil the soup. It's because of what? Qualitative reasoning. In science, you have qualitative reasoning and quantitative reasoning. The two are important. The two are important. As I'm standing here, the first thing I need as a scientist is, without measuring tape, I should be able to estimate with my head, due to exposure to apparatus, the distance between here to certain places. That's why you see some people, they will come. And I do it. I don't know, to some people it's not a way to judge, but I do it to judge some workers. How can I tell you that you are a carpenter? Okay, I don't have people, you don't have people. I don't have the problem you should not come into people. But you can't even give me an estimate. Every check from here to here, what should you do? Let me know what I'm doing. I tell you, I don't need people. That means there's still a separation between you and your work. You people are not yet one. So that is the same way you are supposed to build your mind in physics from now. Now, this thing that we did here, because of time consumption on paper and all those things, science built formulas that replicate the results of experimentation. We don't want to go through experimentation anytime. We want to go through calculated formulas that always mimic the experiment. So, for example, this thing that we did here, instead of drawing the triangle and all these things, we can actually reduce it to this formula. Look at this. X2 minus x1, right? Square. Plus what? Y2 minus y1. What? Square. Then square root. That's what they define as the what? Distance. Let's do it. What are the points? If this x1, y1, this one is what?
X2.
Y2. So tell me, what's our x2? 3. What's our x1?
2.
I mean,
Yes.
square. Plus, what's our y2?
6.
What's our y1?
4.
Or what? Square. Alright, let's go. 3 minus 2 is what? 1 square is what? Plus 4 minus this one is what?
Square.
I mean, when you sum it up, what did you get? It's fine. We passed through a formula to arrive at something that we have to construct a graph. This is not. So if you don't want to open yourself to wasting finance, to wasting time, to wasting, you have to get acquainted to formulas. But that does not mean you should not know the original protocols as to why these formulas exist. You understand what I'm saying? If not, every single time you want to work, I will go and buy a graph. Before you buy a graph, 200 naira come out from your body first. You buy pencil, highlighter, you buy eraser, all this. Yes, it's the truth. But by the time you and the system are now in one, you will not be able to make what? Qualitative assumptions. I don't know if you know what I'm saying. That's the idea. Now, the moment we've gone past the problem of distance, we will arrive at a new problem, the problem of velocity and speed. The problem of velocity and speed. Just that now, the problem of velocity and speed. We arrive at that one. What is velocity? What is speed? First of all, start saying they are the same thing. Start like that. Reason like that, they are the same thing. Yes. Do you know why I want to reason like that first? Because we have to understand their similarity. Work with them as similar entities, that we are working with them as one thing before we start exploring their differences. That's how to know a person. For some people, you want to know two people, or you want to know, you now want to explore differences for you explore. It doesn't just work like that. Everything will be scattering. There will be no consolidation at any point in time. Do you understand? So that is why in velocity and speed, we have to take them first as one thing, because both of them is actually giving you information about rates. I mean, they're both giving you information about rates. How fast are you going? How fast are you going? Let us leave where you are facing to go there. Where are you going? You are going to one energy shop. Okay, you are going to pass by here. Fine. But the point is, we are going to reach my energy shop. Let's forget about how we get there. We shall know that we have to move fast. We must move fast. So that is the idea of velocity and speed. Now, what is this thing that we call speed? Speed is distance traveled with what? Time. Speed is distance traveled with what? Time. Do you get what I'm trying to say? Velocity is what? Distance traveled in a given direction with time or more. Just because of in a given direction, two parameters are no longer the same.
So you mentioned that speed is a scalar quantity because there is no direction.
Yes. I get it now. It's no direction, that's why it's scalar. And do you know the funny thing? That's the only quantity that we have to build on. We build on that quantity like that. I get what I'm saying now. We build on that quantity like that, and then we came to a conclusion. What do I mean? Speed gives us information about how fast we move. Velocity gives us information about what? How fast we move in a given direction. So it means that I can easily tell you that velocity is equals to speed plus what? Direction. So if I tell the person now that I am moving 40 kilometers per hour, this information is what? Speed, right? So what makes the velocity? 40 kilometers per hour east. Now it is a what?
The velocity.
The velocity. Do we get the idea? Do you get the idea? It's as simple as that. It's as simple as that. Do you see that? No hardship at all. Now, you come to what? You come to acceleration. You come to acceleration. Acceleration. What is acceleration?
Acceleration is the rate of change of velocity.
Change again. What did you notice about before these things? Change. Before we know how position is changing. Now, we now learn how to get velocity of position. Only to realize that velocities could change too. Now, the change is happening in velocity with time is the one they are calling acceleration. Do you see what is going on here? Acceleration is now what again? A change in velocity. Do you see the situation of things? This thing here is what we call the tree of motion. The tree of metrics. I don't know. Sorry. Sorry. So sorry for the interruption. I'm so sorry. Okay, so where did I stop, please? Yes, yes. Yes. So, acceleration, let's go ahead. So, acceleration now was not describing another change. A change in velocity. But let me tell you why acceleration was supposed to be an important part in God's design. Listen, everybody. Listen, everybody. I am moving fast is not enough. Because for you to even have moved, then there was something that initiated the movement. That's first one that initiated the movement. If it can be compounded, that is, every single time you are moving, it can take you to another new level of movement. I'm not preaching Bible, I'm just saying something. Because you might think that you are moving fast until another force acts on you and you realize that you can move faster. Right? And there's something that happens with it. There's something that happens when you move very fast. Your weight, what happens to weight? Your weight changes their concentration and you start feeling light. That thing that made you feel light was momentum change. It is momentum that makes you finish the race you can't stop. And sometimes those can just stop. I will make this thing make sense when we get into dynamics. But for now, understand that acceleration came into the picture to be able to initiate an increase in how fast a person is moving. Or look at this perspective. And omniscience, God, some people are not allowed to bring in the religious perspective of this really, but I promise, I don't mean it. But I think that mean any of us are God in worship. Right now, and omniscience God from a perspective just says one thing I understand that like give these people the capacity to move. And don't give them the capacity to slow down, there will be an issue, they will stumble. It's going to be a process. Right? So if for whatever reason, as deceleration has to exist because of what? The need to stop moving at some point. Right? You go somewhere, you get to your house, there's no able to stop moving. The reason why you can stop moving is because you could reduce your speed. You could change your speed. So that point where you are also changing your speed to slow down is deceleration, which is still acceleration. Just we call it negative acceleration. Do you understand now? So we need the two of them. We need the two of them. Yeah, now, acceleration deals with change in velocity with what? And define your maximum. Because when the bike stands moving, because of its light weight, acceleration depends on weight mass. Because of its light mass, they will be able to accelerate faster and reach the highest speed quick. But because of the design of these big vehicles, and I mean big vehicles, they have a lot of things in power. So to quickly take them into such speed, we need time. That is why when you are defining acceleration, it is change in velocity with time. It's in dynamics you now understand the reason why it takes time to initiate that change. You have to work with your pace. Everybody's vehicle is not the same. Dynamics teaches us that. But nevertheless, so what is the other things I'm giving you now are definitive. From the definition, you will now understand the mathematics. From here, we already understand the mathematics of positionality. Now, we said now that velocity is the change in positionality with time. True, of course, is distance traveled with time. It means that I can come here and say that what? And say that distance, that velocity, is equal to distance over what? Time. I will now want to put it in mathematics because this still look like English. But I tell you something. The language of physics is what? Mass. People used to say something. Mathematicians used to say, when I say mathematicians, they really math, but those ones that read maths, they will tell you nature was written in the handwriting of maths. And I used to agree with them. Because that's the same thing as you say, physics was written in the handwriting of maths. Because nature is physics is nature. Right? Physics is the nature we are talking about. To explain nature to a person, to explain physics to a person, you need mass. And what does mass do? Mass reduces the bulk of writing to increase the amount of expression. Because if I was going to write on the board now, some formulas, and I want to use English, and I'm going to write, you just give up the course before it starts. Displacement times fluid viscosity multiplied by this. So you now see that from that is one formula. We now have to use what? Symbolism. That's why they will tell you mathematics can be defined as what? But you say no. Everybody, you did maths in primary school. Probably not for me busy now. No, so now busy. Look at for counting the wheels. Everybody now busy. See, man, you're not busy before you listen to what's maths. Now, sorry. Maths is the science of number. Maths is the science of symbols, numbers, operations, confined by a given set of laws. Who owns those laws? Physics. The operations of those things. Physics now saw that they are going to one day write this as one time, and they will use it to understand that, bro, symbolize it. What do we now do? Velocity now call V is equal to what? Distance D over what? Time. See. Do you see what's going on here? That is it. This is our velocity. I get it now. You know that this distance now I write now, it simply means distance is a given direction. If it's velocity we mean the area. If it's speed we mean it's ordinary distance by what? Don't let anybody stand. You see, I don't want people to have it in mind. When you want to differentiate quantities, you are differentiating them based on the class they fell into. Don't differentiate people like that. It's the wrong thing to do. You don't differentiate people based on class. If I ask you to differentiate between velocity and speed, out of 1 million Nigerians, 900 million plus are going to tell you the difference between them is one speed. Every time. People can't just go out of that office and see something else. Like, talk about these things. Do you know what I'm saying? You should know why they are vectors before you even open up and present vectors and scalars. We'll get there, don't worry. So, the point is that we've confined this guy to symbolism that is understandable. We have that guy. Then we will now come into another person. Acceleration. So, acceleration is now change in velocity that is a change before. You understand me? Velocity is a change in displacement or change in position with time. Acceleration now is now a change in velocity. When we know that velocity is a change in position coming up. Change in velocity with what? Time. Representing the mathematical symbolism. A is acceleration. Velocity, time. But the problem is only now like, oh, sir, this change, I demand want to write this change. Because this one you wrote now, let me not lie to you. Like, why not say? So the whole of change velocity is V. We'll just see V and where change. So the point there is that when we talk about change in something brings that parameter to become a state function. It brings it to become what? And there are two major states. What are they? Your presence and your what? What are the two real states? Presence. What am I saying? Your presence. Your presence and your what? What are the two real states in the person's life? The future is future real. Present of the past. That's why if you want to calculate your change, we'll reference it to your past. Who you are now minus who you were before. I get what I'm saying. Some of you, when you do that, you find out that you are still on your past change. You are still on your past change. Change your lifestyle. Now, velocity is changing velocity. That is, we want to look for a way to bring in former velocity and new velocity. So it means acceleration is equal to, I can write it as V minus V naught, where V means final velocity, present velocity now, and V naught means initial velocity. Velocity before. Because in Nigeria, we not call those things two times. Velocity what? Before. Velocity now. Do you understand what I'm saying? Divided by C. This is an expression for acceleration. So if I tell you that an object is not accelerating, what does that mean? You know that acceleration is the change in velocity of a body, okay? So anytime I want to change a person's velocity, I want to change a person's speed, it means that I have to tell the person to do what? Accelerate. I have to tell the person to do what? Accelerate. So if a person is not accelerating, if a person is not accelerating, what does it mean? That the person is moving with a constant speed. That's it mean. And exams we use the word uniform speed. A uniform motion is a motion without acceleration. And that's shocking. Every single time you accelerate, any single time your speed increases or reduces, a force acted on it. Anything that there is the evidence of influence is like acceleration happened. Imagine you're just moving, you're just in your car, you didn't match anything. You just saw that your car moved front with one kind of speed that is not that match. Nobody will tell you to park and go and check the back, because your mindset is who pushing from the back. You just described and appreciated that it takes only force for you to accelerate and that. If you go back and you don't see anybody, it's not letting to you. You like enter inside back and wait for the second trial or enter back. And go, please. Because I was the one to call my passport. It's not anything that will enter back. We'll be there together in the house. Now, that's what we call the change in velocity in acceleration. Simple words. It's as simple as that. Key. No stress. Do you know that everything we said here is everything about motion? If you understand this thing I said here, there's no question in terms of the remaining is just complexity. The remaining is just a little right. I've used only this formula and that formula to solve more than 1,000 questions. That people will bring in formulas and creating formula in the front and be doing long things. It's the truth. Sometimes it's as simple as an ABC. I was in a, sorry I'm saying this, but I was in a science conference one time. They brought out a question, they projected it. Bro, we were solving. The man said he's going to give $2,000 or so, like last 3 years. See paper and food. Like the length of the paper that I'm not hungry. These people are more hungry than me, forget. People were when the man asked the question, what are we 3 steps? It's 3 steps. It's 3 steps. So, you see, the question was long. So it's 3 steps. Since that day, my orientation was very better. But since that day, my orientation changed completely. It's the truth. So don't be among those that is trying to build complications. Physics is not building complications. Physics is making things easier. Be real. Open your mind to change this. Hello, let me show you what I mean. A car was moving with a speed. Listen, a car was moving with a speed of 5 meters per second. It continues in that speed till he got to his house. What was his acceleration? What do you say? No acceleration. Why? Because he didn't change the speed and me. Now some people now will not carry my marker by the do. The U was equals to 5. As we know, the gravity is always the 10 meters per second. and be doing all those things for something that doesn't have calculation. It's just, you have to first of all be real with yourself. You have to first of all be real with yourself. Do you understand what I'm saying? So that is what physics does, please. Now let's bring out the mathematics from all of this. I lied. You will stop tired. See, you're really happy. Madam, you better sit down where you go to solve. You play. You are joking. You don't ask yourself why did you do this pattern, they're always very quiet. They are always thinking. So wake up, calculus fast. Calculus is the heart of rates. Anytime you see rates, anything has to change with time or it changes because something changed. Welcome to calculus like that. So let me tell you one of you know why I say this thing? And why I say this is this. If you don't know calculus, you can never be a good physics student. You can never be a cramming student. You will continue to does not mean you will not pass the exams. You will be passing the exams. But only you will know that you are leaving school with only results. Nothing is sinking. You can't apply anything. The first day they will give you car to drive, you ask the person why you have to match it also. Because you don't understand charge it. It's the truth. That's because you don't understand why things are happening the way they're happening. And that's why I'm going to do my own due diligence without checking time. That's why I'm not going anywhere now. I think 150 hours to learn physics. I think time just started 10 minutes ago. So on board. So relax, don't rush. Just take time. Now, calculus. Don't worry about you math. Calculus of maths. Calculus of physics. The one you do physics. It don't go far. You see, whenever there is a change, it is calculus that helps to solve any problem that has to do with change. Yes, I was this before. Calculus can help us bring you to what you are meant to be now. And can also take you to who you were before, making use of two tools, differentiation and integration. Integration simply means gather all these person's parts in his past, bring it together and amplify the future. Differentiation means bring this person into parts, see who he is now, the remaining take it back to where he was. So, in essence, what am I trying to tell you? I'm trying to tell you that if you understand what I said, if you differentiate position, or let's say, if you differentiate displacement or distance, who is it? The differentiation of distance or displacement, what do you think is going to reveal to you next? Velocity. You see, that change is following. Differentiate displacement, it will bring out velocity. If you differentiate velocity again, it will bring out who? So if I want to return back to displacement, what should I do to this guy? Integrate this guy. It will take you back to velocity. You will point to integrate velocity again, it will take you back to position. That means calculus. For now, calculus is easier than arithmetic. Go and ask anybody who did calculus. They will prove it to you. If they do not show you that they failed many papers in calculus, don't believe me. They will show you how easy calculus is. Very, very easy. You don't need to stress yourself. Now watch you. Changes. That's what the story is. So, just so we don't waste our time, right? If you have, everybody listen, if I write 4t cubed plus 3t squared, and I say that x is equal to this thing. Follow me up. And I say x is equal to it. Do you know the meaning of this statement? No, relax. Okay. Because I told you what. Okay. Let me change my noun. Let's say I have a 3a plus 3ah plus 4h equals to, let me put G here, B. Oh yeah. G equals to 3H plus 4H. Let me put cube in this side. Do you know the meaning of this statement? Who can tell me the meaning of this statement? It means that I don't know what G is, but who G is going to be depends on what H is here. Because if H is 1, G is going to become 1 is power 3. 1 times 3. 3 plus 1 times 4. 4. Now, if H was 1 in this place, G would have ended up becoming 7. That's what we call dependent variable. So it means that it is the changes in who that affect who. Changes in H is what affects who? G. So since it is changing in H that affects G, if I want to write that statement in differentiation form, I will say that the correct way to write is that dH over dG. This means change in H due to what? I said, sorry, dG. I want to ask you a question. dH. What does this statement mean? This one means changes in G in respect to what? H. I'm coming home. There's another way again a person can write this kind of statement. Now, changes in H over this one now means what? Changes in what, everybody? H. In rest. I'm not telling you that that's what it is here. I want to first of all introduce the statement. Changes in H in respect to G. Between these two statements, based on what I explained about this, which statement do you think is correct? Which one? Because you know it is the value of who this person is that determines who this one is. I mean. So, which of these two statements is portraying us? Is it the first or the second? The first one, I mean, because the first one is showing us, it's trying to tell us that that there will be changes in who? In this G. That is as a result of who? Changes in what? H. Understand this is the study of relationship. How a change in one parameter causes a change in another parameter. Yes, so go and meet psychologists. I have a psychologist friend, a person. He will make you understand that any two people that have issues, it is one person's change and she said the other person's change. The truth about the matter is that nobody, the conflict of the issue now becomes nobody wants to accept the face to change. Because change was always happening constantly. It's the truth. So understand this part of it first. You will now understand why if I write this, do you expect me to write change in T over change in S? I mean ds over dt. What do you expect me to write? Thank you. So the thing I'll do here is dx over dt. Follow me. You know that x is distance or position. So that means this thing I've written here is change in x in respect to what? Time. Who did we say is change in displacement with time? That means by differentiating x, I got who? Velocity. If I now write another function, v is equal to 4t minus 3t squared, what does this thing mean? Whose change is affecting another person? It is the change in t that defines who v will become and me. True of us. Now I'm coming somewhere. Because since I'm just trying to break the language for you. The correct words I'm supposed to use is variable. There are two types of variable. Independent variable and dependent variable. Why do we call them variable? Because both of them change. You know, when you say something is a variable, the common word varies. That means a variable a set of numbers that have the ability to do what? Change. It's just that one usually change first, and the other one depends on the changes of that one. So between Between G and H, who do you think I will call the depending variable? Oh, bless you. Because now G dey wait for H to become wetin wan become. So you go know wetin he wan become. Abi? So that means G is the depending variable, while H is the what? Independent variable. H is not depending on G. H is just going to one day decide that this I want to change. So I want to change. Let me see how this one change. And that's children for you. Children, wetin concern them? You do their thing. When they do their thing, they wait to see how you react. Or they not beat me. Do it again tomorrow. Then they increase the amount I do. It's the truth. That's what is going on in their brain. Because I know that when I did this, when I do something I'm not sure of, come and no beat me, came with it. I will just try to amplify it more. Understand? You keep applying. So that's it. So in this place now, how do you write the statement? Am I going to write the V dt or the T dv? The what? Thank you. dv over the T. Because I told you the one up, this statement, the thing up is changes in the thing up in respect to things down. And the things down are the ones that are usually inside the equation. So with the way they arrange this equation, that is, it is changes in this person that determines who this one become. Right? So if I want to write it in state, I'm saying changes in G as a result or in respect to the changes in T. So that the V dt is another thing. Now check among these things you have written. There's something we wrote, the V dt. Who be the V dt? Oh, thank you so much. Who be the V dt? Accelerationally. So